Hello and welcome to Builders, the podcast where we speak with the leaders shaping the future of technology, data, and business. I'm your host, Lee Haynes, and today's guest is Liniker Seixas, Senior Staff Data Scientist and Team Lead at Truecaller. Liniker has spent years building data science teams that don't just experiment, they ship. And Truecaller is a fascinating place to do that. It sits right at the intersection of trust, communication, and adversarial behavior, where the product has to work in the messy real world, not in clean toy datasets. A quick bit of context for the listeners. Truecaller, the world's best caller ID and spam blocking app, as a company refers to itself, has grown to 400 million plus monthly active users globally and keeps expanding, largely by tackling a problem that's getting worse everywhere: spam, fraud, and unwanted communication. So today we'll talk about what it takes to make data science practical at that scale, how to structure teams realistically, how to hire for the right traits, and how to stay focused on outcomes when the data and the world keep shifting. So Liniker, warm welcome to Builders. How's it going?
All good. Excited for today's podcast. And yeah, looking forward to divulging deeper into how data science teams are built and things that you should look forward to and not. Yeah.
Fantastic. Well, let's dive into it. Let's start at the beginning. I mean, you've spent years leading and scaling data teams, right? Tell us a bit about your background and what first pulled you into data science, and how your view of the field has changed as you've moved into leading roles.
Yeah. I think it was, when I just started, this was like 8 or 9 years back. I remember first playing around with data, and it got me so interested just by looking at structure and how you could sort of move unstructured data into structure and derive some business value out of it. So my career began as an intern. I slowly moved in analytics. I slowly moved into analytics engineering, and then data engineering, and finally data science. So I've been at different stages within the data science lifecycle. And to answer your question, what initially drew me to data science was the sheer power of prediction, that you could essentially find non-obvious patterns in large data, in big data, as they say. And I think over the years with experience, it sort of evolved into an applied product discipline, at least to me. That's what it looks like. And I started getting more interested in the whole cycle of data science, not just data and modeling, but rather delivering these insights. How does it make it to the client? What sort of things you need to look at? So I think the challenge behind it was seeking a lot of discomfort, which I truly enjoyed. And secondly was to be able to create end-to-end sort of features when it comes to the data science end. And then I essentially stuck with it. And I think that was the kind of high that I was riding for a very long time, and I'm still riding. And I think at the rate at which data science is growing, it is definitely, there's a lot of potential. It's endless potential. But yeah, primarily starting with just the sheer power of prediction and eventually to complete life cycles of data science. Yeah.
Really nice. And in many organizations, I feel like data science is still looked at or kind of still treated like a magic function, right? But without the right kind of plumbing or ownership, I mean, even like the strongest models don't survive contact with reality, right? When you think about building data teams today, what do you think most companies, especially smaller ones, tend to get wrong at the very start?
I think, as I believe and as I have seen, at least, is basically the magic wand fallacy, right? You go out there and you expect to hire maybe 2 PhDs, and let's call them your unicorn data scientists. And you expect them to solve all the problems. Now, the problem lies in how data science is viewed. It is essentially a mindset, right? And we have to go back a few years to kind of figure out why this happens. When data scientists just came, everyone was super excited about modeling, predictive power, and F1 scores and accuracy and basically vanity metrics, right? Which makes absolute sense, right? In any sort of technological advancement. But as we moved further down the years, the need for engineers to support data scientists became very, very important and a requirement. So I would say that coming in or starting a new data science team, the first thing that you do is hire 2 really good data scientists and expect to get business impact out of it, you're highly mistaken. That's not how it's done, right? Now, for every data scientist, they require a bedrock, and that bedrock is data. And you need data engineers to help create that data pipeline. So a foundational sort of structure is everything in this case. But I still do think the magic wand fallacy is the reason why a lot of small companies try to figure out why isn't data science actually giving us the kind of output we need. We see other companies doing it.
Yeah.
But that's not a holistic picture of everything.
No, I agree. And I think it's, companies often expect, maybe through lack of experience, I'm not sure, but they often expect that data scientists do everything, right? Analysis, modeling, deployment, monitoring, like basically end to end on their own, right? And it's like, talk to us a little bit about why that setup is not sustainable long term.
Yeah. So I think let's give an example, right? You have a data scientist coming in, and they are supposed to solve a big problem regarding revenue, or rather drive revenue in different ways. Our data scientists, by nature and by their responsibility, are supposed to focus on discovery, insight, and of course modeling, right? And then you have MLOps and ML engineers that focus on maintainability, scalability, and other stuff with respect to getting these juices flowing. So what happens here is your data scientists might ship something out quickly, right? Because they are designed, or they are built to learn the cycle of optimization. How fast can we experiment? When you expect your data scientists to do things that are outside the scope of their work, or you expect them to be a generalist, they spend less time on something that they're good at, and they spend more time at something that they're not good at. So what happens is you have a data scientist that's actually doing about 10 to 15% of data science work and is doing 70 to 75% of deployment, maintaining, and scalability. So this is like, it's essentially digging your own grave, right? It will catch up to you. You might survive for the first 2 projects, but eventually when you hit a certain amount of scale, you need certain engineering principles, just as software engineering principles are written down. Data science is one part of the life cycle of a larger feature, so it needs to be supported. We're not superheroes.
No, very well put. And in your view, what does a realistic kind of well-balanced data science team or data team look like, especially if you're building at scale?
I think a well-balanced team is a cross-functional triad, right? And how I always like to see it, you can have it as a triad or even more, but there needs to be one data scientist, at least. Let's say, for example, a single data scientist, an MLOps / data engineer, or an MLOps engineer, ML engineer, data engineer, depending upon which level of maturity you're in your organization, and a dedicated product owner. Without these 3 pillars, it's going to be very hard for you to succeed in data science. And I can tell you exactly why. So data scientists are focusing more on model development, experimentation. And again, your MLOps or data engineers are focused on creating the bedrock of information or productionizing your models, right? Making sure that they're scalable. And of course, a product manager is always there to help us with direction in terms of what the business impact is, what we should be measuring. Yep. A lot of data scientists sort of think about vanity metrics as everything. Oh, I got this great F1 score or this accuracy, but that's not enough. The question is, how do I use this F1 score to bring a 5% improvement in retention?
Yeah.
Or how do I use this F1 score to bring a 5% improvement in revenue? That's how your thought process should be. And often data scientists believe that, okay, my model has been trained and my metrics look good, my job is done. That is absolutely not the case. You need to be present at every single part of the pipeline, and eventually also when it's in production, it's still your responsibility. So I think a well-balanced data science team should first start with hiring a data engineer, building that bedrock, then bringing in data scientists. So I would say for every data scientist, you need to have at least 2 engineers supporting that data scientist. That's the only way you can actually live up to the cycle of optimization in a short time and allow data scientists to do what they're really good at.
Yeah.
But yeah.
But looking at it from like a Truecaller perspective or angle, I think Truecaller's kind of highlighted the modern spam and fraud, including these kind of AI-driven scams, which we'll talk a bit more about later. They evolve really, really quickly, right? So AI teams can't treat models as these kind of, one and done, and just be happy with it. What does your kind of operating rhythm look like, or how do you organize your team and ways of working to keep models fresh and this kind of fast adapting threat landscape?
Yeah, I think it all boils down to structure in your planning and development, right? So when it comes to essentially looking at features and ensuring that, that there is a high amount of success, you need to also balance resources, right? You need to try and figure out what minimal example that I can get out there is indicative of success, right? Can I get that out there pretty quickly so that we start investing more resources? And how I like to essentially approach this within Truecaller is, instead of saying that a project is going to take 8 months to deliver, why don't you go back to the drawing board and think about how you can deliver within month 1? Because then you have some sort of incremental delivery, right? You have delivered something. And we all know that if you solve 20% of problems, you are going to get at least 80% of improvement in your metrics, given that they follow the Pareto rule in some way. So I think just being strategic about your plan, having a long-term vision, right, that is everything. When you think about, I'm trying to solve this problem, don't think about today, think about tomorrow and day after tomorrow. And that will essentially help you deliver the most important pieces early on, because you might have an item that is maybe 4 years down the line, but it makes absolute sense to do it in the first 2 months because it's an easy, low-hanging fruit. So I think everything is etched into like structure, vision, planning, and then finally execution. But it has to be driven by strong product and business acumen, because that is the goal, right? We all work in product companies. It's definitely not a research company. So numbers need to go out and they need to go out fast.
Yeah. It's a really, really good point, actually. And I think, do you think that's kind of the main difference between teams that ship successful data products and those that do not, this kind of iterative outlook?
Yeah. I think when teams, it depends on what is a stalling product and what is a successful. How I would say it is that a flawed model that drives business impact is a successful model, rather than a model that has been built correctly and has been shelved. Right? So that is a very important aspect of it. And I think it is also etched into how much data scientists know about the business. Right? As like I mentioned earlier, right? As a data scientist, you believe your metrics look good, you believe your work is done. But it does not end there. This could literally mean that, you believe that your work is done. F1 scores are extremely good. We've used engineers to deploy this model. Now product is saying it's not moving our KPIs at all. That is worse than creating something that is subpar. So I think it is, again, it's all about experimentation. To make sure that you run enough experiments. When you have a hypothesis, you prove the hypothesis. It becomes a theory, right? But that's not it. There is still an exhibition in the real world environment. So you cannot really say that this is successful. So at the end of the day, it's how we look at it. What is the definition of done here? Does done mean, I'm done with my model? Or does done mean that I have successfully moved the KPIs for 3 months in a row? That's what done looks like to me.
And talking of that definition of done then, in terms of kind of, how has it kind of impacted the business KPIs really? How do you keep your team anchored to business and product outcomes? We mentioned that kind of role of product owner or whatever it might be, maybe as that kind of translator earlier, but how do you keep your team anchored to business and product outcomes?
Yeah. So it's essentially whenever we have somebody joining our team, we implicitly or rather, sometimes I explicitly kind of mention that as a data scientist, you need to wear the hat of a product owner. This is the only way you can succeed in a product company. So what we essentially do is allow data scientists to sit very close to product. So you have a triangle, and data scientists are on one point, and then you have data engineers, MLOps engineers, and you have product. If you have one side missing of that triangle, you're in trouble. Right? You're just building things for the heck of it. They might be technically sound, they might be scalable, maintainable, they might make it to GitHub, but are they of any use is the question. So slowly, like initially, there has to be a lot of inculcation of product knowledge and also product acumen. Without that, you're going to end up in a very bad place.
And at Truecaller, how do you measure success when the goal might be something that's quite fuzzy, right? But it's critical. It's like safer communication, right? Do you have these kind of concrete signals like spam or fraud volume that are blocked, or like how do you measure success?
Yeah. So for us, what is success, right? And it has to come from the user. For us, success as a metric always comes as feedback from the user. What the user is saying about a certain thing that we have done. Maybe spam classification, fraud, scam. We do a plethora of contextual signals. That's what differentiates us from your typical players who just provide names. There's so much more that we provide that helps you sort of identify who is calling you and who can tell us that what we're doing is correct, the user. So we have a lot of feedback flows across all our features, which essentially allows us to talk to the user in an automated way. Like, hey, this is some sort of classification that I've done. This is now a spammer. You tell me what you think about it. Okay, it's not a spammer. It goes back into our models. We fine tune it. And then the next day, it's not a spammer. So it's not the fact that we only listen, but we also react very fast. But our success metrics are very rooted into user feedback.
Yeah, so these are kind of user feedback, user reports, retention ultimately as well, right?
Yes, precisely. So you have retention, you have growth, and these are sort of our guardrail metrics, right? Even though we're looking at maybe how well our spam model is doing, we still want to see what the impact is on retention. And so for every experiment, you need to have baseline metrics, and then you have your primary metrics on top. As we call them, they're like guardrail metrics. Maybe something you're doing is not related to retention, but there is an unintended effect on retention. So it's always good to keep your eye on more things. Yeah.
And Truecaller, I believe, has said it's kind of identified, 56 billion plus spam fraud calls, 173 billion plus spam or fraud SMS just in 2024. So we're talking colossal volumes here as well, or kind of potential colossal feedback as well, right?
Yeah.
Can you share an example maybe of like a data initiative that looked maybe promising on paper, but only became valuable after you reframed the problem around like the real kind of user behavior?
Right. I think one could be spam. And how we were looking at spam before is essentially we didn't really know a lot about spam initially. And I can tell you why that happened is because we thought once a number is a spammer, it's a spammer for everyone, right? But moving forward, we learned a lot about our users. And this is many years back, right? And what we learned is that spammers the perspective of a spammer is very different for different people. A good example is, hey, I'm right out of college. I'm 19. I receive a call from a real estate agent. Is it relevant to me? No. He's called me 5 times. He's a spammer to me. But I'm 35. I have enough money in the bank to buy an apartment. The real estate agent's called me. It's important to me. So we realized that a one-size-fits-all approach will not work. And it looked good on paper, and we sort of wrote it down, and we started tackling this problem individually, right? And we started splitting our models by country. And we started splitting it by regions, and we saw substantial increases. So that was a good example of how we took a step back. Even though we knew that our spam models are good, we took a step back and started to question everything that we did. So always going back to your fundamentals, regardless of where you are in the data life cycle of a given model or a project, you need to remember your roots, because it's how you sort of navigated through your roots to get here, right? And it shouldn't be sort of fire and forget. But that's a good example of how we did it. And now we have different models running for different markets, and they are sort of curated for those markets. But also looking further on into more personalization for users, because that's where the world is heading, right? We all want personalized, relevant experiences. If we have to see ads, we'll see it, but at least show me what I want to see.
Yep.
So yeah.
And to talk a little bit more about these kind of models and the way that you're working with them, I think just to kind of give a bit of context here, the company, the product Truecaller, is kind of sits at this, it's a genuinely kind of adversarial arena, right? It's this constant cat and mouse game where you're working against an active opponent, right? Scammers, spammers, they're adapting in real time, and you're kind of defending the user trust, right? You're not just predicting behavior then, you're kind of outmaneuvering an opponent that learns and adapts really fast. And all of this kind of made me think, when I was thinking about it earlier, is this funny or kind of, lighthearted, but very, very serious example of work that's been done in the arena in the UK. You probably saw this, a lot of kind of videos or ads where the company O2 built this AI granny, right, called Daisy, that kept these phone scammers busy. It was AI, it just kept these scammers busy for ages, chatting about all sorts of things, knitting, recipes, whatever it might be. So it's just wasting their time. And it's really, I would implore anyone to kind of, look it up and watch it, because it's really funny. But it shows something serious, right? That the attackers, they try to adapt fast, and so must the defenses, basically. So Truecaller has spoken publicly about this kind of real-time call screening and AI-assisted voice scam detection, yada, yada, yada. I'm just interested to hear, like, in this kind of cat and mouse, as I said, environment like yours, how might it kind of change the way you build the models and your teams compared to these maybe more normal machine learning problems? Do you know what I mean?
Yeah, for sure. I know what you mean. And I think this is something we also learned. We knew that there was a cat and mouse problem, but we didn't believe that it's so malleable in nature. It changes so much from day to day. And what happened was we sort of created models that would essentially be trained on some amount of data and predict on the future. And we believe that, okay, this would hold ground given that you trained on enough amount of data, maybe a year. So you capture seasonality. But we realized that patterns change drastically. And for us to identify what patterns change drastically, you need a solid pipeline in place. You need components that check for drift changes. So a drift is like, okay, your features have changed massively, or your model predictions have changed massively.
Yeah.
And that helps you identify that, okay, it's the right time to retrain your model, right? And this is where user feedback comes in. If we don't have user feedback, we would be unaware of these patterns changing. It's the users that are literally telling us that this seems off. So you guys need to go and fix it. And that's how that loop is maintained. So as of today, for every data science project, we think about continuous learning. How do we allow these models to train and learn by themselves without a lot of human intervention? Because as you mentioned, at this scale, we're doing so many different things. We have a multitude of models. It's impossible for data scientists to constantly be looking and sort of having manual interventions. So that's something that's become part of our core development. And how do we focus on this model growing rather than saying, I've created this product and now I'm washing my hands. Yeah.
And to talk a bit about hiring and kind of your kind of talent philosophy, let's say, I think you've spoken about hiring for drive to learn over this kind of perfect CV fit, right? What does drive to learn look like for you in an interview room? How do you spot it?
Yeah. So for me, I guess it's a hard thing because it happens intuitively, but yeah, we can talk about it. And I think for me, it's about first curiosity, right? And what does that look like? Is the candidate asking you about salaries or what Python version you use, or are they asking you about the way you build things, system design, how does the team work with each other, what sort of boards do we have, and trying to sort of attach themselves closer to the role that they probably may or may not get. And also asking questions that they probably don't have a clue about, right? That's sort of the curiosity that I like to see, right? And when it comes to learning, I sort of use this strategy, right? And it's a simple one. Can you tell me about a project that you worked on where the requirements massively changed over the period of the project? And the answer that I would not expect is that, yeah, the requirements were not properly defined, so that's why the project was not successful, sort of complaining about it, right? But that's not the way to go. Rather, you want to evolve your way of working. Requirements will always change. We don't live in a perfect world. We're not trying to find the vaccine to something, right? Requirements are definitely going to change. So more elaboration on that I went back to the drawing board, spoke to my product owners, made sure that the engineering requirements aligned with the product requirements, sort of showing that ability to seek discomfort and also that ability to learn. It was a language that I never knew of, but yeah, it's okay. We all learn programming languages throughout our careers, right? So it shouldn't be sort of a area where you want to step back. It's something that you should jump into. And these are the sort of questions we try and figure out that whether this candidate has that appetite to learn and the appetite for curiosity.
And how has this approach shaped your team at Truecaller, especially in terms of not just hiring but also growth, internal mobility, people stepping into different or unexpected roles, for example?
Yeah. I think with data science, internal mobility is not that hard to do. Now, the thing is, as a data scientist, you can move to an ML engineering role because you understand the nuances of data science. You can also move to a data engineering role because you know how to look at your data, you know what skewness means, you know what partitioning means, and so on. So I think, at least within Truecaller, internal mobility is always supported. But of course, for data scientists, it's easy to move within the data domain, right? And within the team, our ideologies or the way we think has allowed our data scientists to be comfortable to do things that's out of their sort of realm of responsibilities. For example, we have data analysts that are sort of looking at complicated Spark pipelines or data pipelines when our data engineer is away. So they don't shy away from doing these things. They understand that these are not our responsibilities, but I'm excited. I want to learn. This is new. Where can I provide value?
Yeah. I think it's really interesting as well, because we were just talking about how quickly or how fast the opponents might kind of adapt. And these are kind of fast moving areas, right? Spam and fraud detection, where the attackers are changing tactics all the time. So what works today may be obsolete in a few months or 6 months time or whatever.
Or even tomorrow.
Yeah, exactly. That's why this kind of curiosity, adaptability often beats the narrow, perfect on paper expertise in the long run, right? How do you spot candidates who might keep learning faster than the adversary evolves, for example? Yeah.
So, I mean, that's something that's not easy to do. You sort of understand that now figuring out whether a candidate can learn fast or not, there's not sufficient amount of time for you to do that. But what we do is in that 6-month period when you are hired, these are things that are put on the table as goals. Your ability to learn fast. Now, the problem with Truecaller, or not a problem actually, it's a good thing, is that we use a variety of tools. We allow our data scientists to use the languages that they prefer, given that it is efficient and scalable. But there might be a case where you join and you're really good with Python, but you don't know anything about R, and we have an R pipeline that you need to fix. And then tomorrow you might have a Spark pipeline. So it's not only about this sort of sequential thought. You should be able to parallelize your learning so that you adapt to the resources and tools available in the organization. And as we know, data science is a rapidly growing field. That means the number of tools around it are massive, right?
Yeah.
So I wouldn't say it's easy to figure out whether somebody has an appetite to learn, like you can figure out whether someone has an appetite to learn faster during the interview, but you can certainly do it within the first 3 to 6 months.
Yeah, absolutely. And in addition to these kind of, curiosity, adaptability, these maybe softer skills as well, when it comes to the kind of technical depth and the harder skills, how is that kind of, how you assess for that and evaluate that, how has that changed over the past few years, with the introduction of, a plethora of tools, AI and everything like that? How has that kind of impacted how you assess for the hard skills aspect? Because it's still important, isn't it?
Absolutely. The thing about data science, if you do not stay relevant, you'll be left at the station. The train has gone, and you will have to put in 3 or 4x amount of effort to make it happen. So I think data scientists by nature know this, and it is basically they're scared of being irrelevant. Right? Everyone is scared of being irrelevant, and especially in data science where it's growing, you need to read a lot. You need to be on top of your game when it comes to what papers are being released, how people are solving different problems. And even though you may not have an exact use case for a certain thing that you would want to try, I would suggest outside your working hours, if you're really passionate about it, try a toy example. Try to get your hands dirty so you know how to use certain things, right? A lot of people, agents are going around quite a bit, right? But a lot of people haven't used agents. They've read a lot about it. But I would suggest that you actually get your hands dirty so you know little nuances about it. So it's all about being relevant, and it's all about your passion and motivation. If you don't have these things on your plate, you're going to be stalled in your career and end up being irrelevant. And of course, eventual termination. Yeah.
Yep. It's a good way to put it as well, being left at the station.
Yeah.
But you also mentioned earlier about, making sure that maybe the first couple of hires were really, really kind of quite senior, quite good, data scientists, for example. What role do you think these senior hires play in balancing, experience in the team with fresh talent on the team as well?
Yeah. I think the main point of getting sort of senior folks within the team initially is to set the bedrock for your technical strategy, right? Your long-term vision, your ways of working, how certain things need to be done. Now, you can also hire a few senior folks along with some junior folks, but if you really want the senior person to deliver something in that time, it's going to be hard because he's busy sort of mentoring junior people, right? So if you bring a lot of senior folks to the team in the beginning, not a lot, but a few to set that foundation right, then you're setting yourself up for success, even for people that would join later. Up for success. So that's the whole thought process. And most senior data scientists have a generalistic view of the entire data science lifecycle or pipeline. I would say that if you're like a senior and a staff level, you have a very good idea of how models behave in production, how certain data pipelines are built. So let's say you are a product owner, you lead the team, and you have no knowledge of data science. You would need somebody senior to set this up for you. Right? In the domain. So that's the thought process behind it.
Yep. It's kind of the infrastructure question, getting it right in the beginning, as opposed to having to rebuild later on. And to talk a little bit about leadership and long-term vision here as well, I believe you've described your philosophy as setting a constantly evolving 5-year goal, right? Like this continuous optimization loop. Can you unpack what that looks like in practice? How does it work?
Yeah. So I think a 5-year goal shouldn't be a rigid, static document in a drawer. It should be a directional compass, right? Our cycle is essentially, what is the vision? What does a fully optimized data product look like, right? And this would be, of course, it's hard for you to figure out in the next 4 years or 5 years what your data product might look like, but you should have some sort of idea, right? And I think this all stems from a question that my CEO asked me a few years ago, which was essentially, Liniker, what's your plan with a project that you've been working on, right? And I was, what was your 5-year plan? And I said, I don't know, actually. I had the 2-year plan in my head, but I was like, who even thinks about 5-year plans? I went home and I sort of looked at everything that we thought of. And I also looked in the past and I realized all of these things could have been jotted down earlier. Why are we doing everything at a whim? So having that directional compass, at least for the next 5 years, helps you achieve long-term goals, helps you understand what your next roadblocks are, what your next increment is, right? Certain areas you might sacrifice a short-term goal to achieve a medium-term goal, or you sacrifice a long-term goal to achieve 10 short-term goals. So it's all about balancing your sort of delivery over the year and understanding what impact different things could have. And also there's another variable. There's so many variables that could change all of this. One is your overarching business goals have changed massively.
Yep.
And now something else is applicable versus what you thought was applicable. So I think it all boils down in having that directional compass. It should be there. And if it's not there, that's a red flag for your team.
Yeah. And I think it's a really good, you mentioned kind of directional compass. I think it's a good way to put it, because it's nice to get, like, from my position as well, it's nice to, there's so much focus on the here and now and what we're doing short term and the impact it has on the business, but it's nice to also look years ahead and actually say, okay, well, where might we be in a few years' time to actually get your head out of the mud, essentially. But the fact is that it's okay to accept that things are quite likely to change during that period, right? What might be relevant now is not relevant, say, in 2 years' time, when you're kind of planning for years ahead. And that's the key thing. But you also mentioned this kind of balance, right? How do you balance these in practice here? How do you balance the long-term bets with the pressure that often comes to kind of deliver short-term visible wins, basically?
Right. So, like I said, right, long-term goals, even though they're long-term, you need to learn how to break them up into smaller pieces. So much so that each piece delivers some value, right? When I say long-term goals, yes, it might take a year to deliver this. In the same example, I'm sort of dialing back to what I said earlier on in our call, was essentially that you can find a good balance between the two, given that you understand how to break down your long-term tasks. Without doing that, you are essentially going to lose out on a lot of short-term value, which basically management wants. They want to see results, right? So I think sometimes you will have to give up certain things, but at the end of the day, you need to focus on your overarching business goals. You're solving for the company, you're not solving for yourself and the team.
Yep. And looking ahead, I think as we kind of move towards kind of wrapping up here, what's your vision for how your teams or data science teams should mature as like a discipline, especially as AI grows, and AI tools get easier to use, because these expectations keep rising as well, right? So how do you, what's your vision for how your teams will grow?
Yeah, so my vision is essentially that data science becomes a boring and reliable utility. And I mean that in the highest compliment possible.
Yeah.
What does that mean? It essentially means that everything is sort of automated in this well-oiled machine. You are experimenting, you follow ethics, you follow privacy, guidelines, and your focus is on execution. Data scientists should not spend months on projects, they should spend weeks on projects. And if everything around them was sort of there, enabling them, they would definitely be able to achieve it. No matter where you're sitting, if you have the right tools and support, you would be able to do it if you're in the field. So that's essentially where I see it going. Boring, reliable, but yes, that's exactly what we need.
And what's finally from you, what's one trend in data science or like applied AI that you think most people are underestimating right now?
Yeah. Classical machine learning. That's what they are underestimating. I'll tell you why. And I might maybe unpopular opinion, but when it comes to LLMs and other language models, a lot of people are using them for simple tasks, right? And these are, I can tell you a good example. It was me. I was essentially typing out something and it was in caps. The case was uppercase. And I pasted it into ChatGPT and I asked, can you make this proper case? And that's when I was like, no, I'm done. I cannot be doing this. So I do use ChatGPT for the right things, but not for everything, right? And a lot of, I think, people sort of create end-to-end projects that are based off ChatGPT. It's like vibe coding, but you have these engineers that spend hours and days and months trying to fix it and make it more reliable. So I would say the trend is that we're leaving classical machine learning for very complex things that we are still yet to understand, right? And that's a trend I definitely don't support. It's all fundamentals in data science. The simplest, the most complex problems can be solved with the simplest techniques. You can throw complex things at it, but you're just wasting money and resources. And LLMs cost money. They're connected to GPUs, and GPUs are expensive. So these are things that you need to think about as an individual and also as a data scientist. And that's what I feel we're missing out. We're missing out on what data science really was and is.
And any tools or kind of methodologies that are actually really kind of exciting you right now? Anything that you're experimenting with at work or kind of personally as well?
Yeah. I think what's been exciting for Truecaller as a whole is that we have been dabbling in the space of recommendations. And it's pretty cool to move into that arena because it's what the world wants. As we see, personalization happens across Spotify, YouTube, you name it. You're getting curated things. Instagram gives you personalized results with every scroll, right? So that was pretty interesting for us because Truecaller as a company, we're no social media app, right? We use recommendations for ads and other things within the app. So it wasn't a very high priority. But once we really started getting into it, we could see the value, the direct value from it. So that has been something that has been on our map, on our radar. And we have, I think, multiple teams just working on different recommender problems when we never touched them for the last 10 to 11 years almost. So that has been quite interesting.
Really, really cool. Well, fantastic. I think, before I wrap up, is there anything you would like to add?
Not really. The last thing I would add, I think for smaller companies, do not hire unicorn data scientists. This will eventually lead to burnout and eventually lead to unsuccessful projects. Think more about the entire data lifecycle. Think more about your data engineers, MLOps engineers. Think about a data team, not a data scientist. That's all.
Well, a smaller company and bigger ones as well. We hope you're listening.
Yeah, of course, for everyone. Yeah.
Exactly. And let's hope they're listening. So Liniker, thank you so much for joining us today, sharing your insights, your honesty with us today. I think it's been a lovely kind of take on, not necessarily needing to be so romantic about AI and being more kind of constructive about it and kind of real, right? So thanks so much for joining us.
Thank you so much, Lee.
And to our listeners, if you enjoyed this conversation, subscribe to Builders, share it far and wide, particularly though with anyone trying to build data-driven products that actually ship. Until next time, keep building and we'll see you soon.